Assess security in your IoT workload. To assess your IoT workload through the lenses of the well-architected framework security pillar, complete the security questions for IoT workloads in the Azure Well-Architected Review. After the assessment identifies key security recommendations for your IoT solution, use the following content to help implement the recommendations. Design principles. 5 pillars of architectural excellence underpin the IoT workload design methodology. Strong identity. Use a strong identity to authenticate devices and users. Have a hardware root of trust for trusted identity, register devices, issue renewable credentials, and use passwordless or multi-factor authentication, MFA. Review general Azure identity and access management considerations. Least privilege. Automate and use least privileged access control to limit impact from compromised devices or identities or unapproved workloads. Device health. Evaluate device health to gate device access or flag devices for remediation. Check security configuration, assess vulnerabilities and insecure passwords, monitor for threats and anomalies, and build ongoing risk profiles. Device update. Continuous updates to keep devices healthy. Use a centralized configuration and compliance management solution and a robust update mechanism to ensure devices are up to date and healthy. Monitor system security. Plan incident response. Proactively monitor for unauthorized or compromised devices and respond to emerging threats. Most IoT systems use either a connected products operations architecture pattern, connected operations architecture pattern. You can divide security in an IoT solution into the following 3 areas. Device security. Secure the IoT device while it's deployed in the wild. Connection security. Ensure all data transmitted between the IoT device and the IoT cloud services is confidential and tamper-proof. Cloud security. Secure your data while it moves through and is stored in the cloud. Device security. Scope hardware to minimum requirements. Select your device hardware to include the minimum features required for its operation, and nothing more. For example, only include USB ports if they're necessary for the operation of the device in your solution. Extra features can expose the device to unwanted attack vectors. Connection security. Ensure you have a way to update the TLS root certificate on your devices. TLS root certificates are long-lived, but they still might expire or be revoked. If there's no way of updating the certificate on the device might not be able to connect to IoT Hub, IoT Central, or any other cloud service at a later date. Cloud security. Follow a secure software development methodology. The development of secure software requires you to consider security from the inception of the project all the way through implementation, testing, and deployment. Azure services supporting IoT security. Azure Sphere Guardian modules connect critical legacy devices to IoT services with zero trust capabilities, including strong identity, end-to-end encryption, and regular security updates. Azure IoT Edge provides an edge runtime connection to IoT Hub and other Azure services and supports certificates as strong device identities. IoT Edge supports the PKCS #11 standard for device manufacturing identities and other secrets stored on a trusted platform module, TPM, or hardware security module, HSM. The Edge Secured Core program validates whether devices meet security requirements for device identity, secure boot, operating system hardening, device updates, data protection, and vulnerability disclosures. The Edge Secured Core program requirements are distilled from various industry requirements and security engineering points of view. Windows for IoT uses Windows, embedded experience, ecosystem and cloud connectivity, allowing organizations to create their Internet of Things with secure devices that can be quickly provisioned, easily managed, and seamlessly connected to an overall cloud strategy. Microsoft Defender for IoT is an agentless, network layer security platform that delivers continuous asset discovery, vulnerability management, and threat detection for IoT and OT devices. Defender for IoT continuously monitors network traffic using IoT-aware behavioral analytics to identify unauthorized or compromised components. Defender for IoT supports proprietary embedded OT devices and legacy Windows systems commonly found in OT environments. Defender for IoT can inventory all IoT devices, assess for vulnerabilities, provide risk-based mitigation recommendations, and continuously monitor devices for anomalous or unauthorized behavior. Azure IoT Hub provides an operational registry for IoT devices. IoT Hub accepts device operational certificates to enable strong identity and can disable devices centrally to prevent unauthorized connections. IoT Hub supports provisioning of module identities that support IoT edge workloads. Microsoft Defender for IoT is a unified security solution built specifically to identify IoT and OT devices, vulnerabilities, and threats. Use Defender for IoT to secure your entire IoT, OT environment, including existing devices that might not have built-in security agents. Defender for IoT provides agentless, network layer monitoring, and integrates with both industrial equipment and Security Operations Center (SOC) tools. Agentless device monitoring. Defender for IoT uses agentless monitoring to provide visibility and security across your network and identify specialized protocols, devices, or machine-to-machine (M2M) behaviors. Discover IoT, OT devices in your network, their details, and how they communicate. Gather data from network sensors, Microsoft Defender for endpoint, and third-party sources. Assess risks and manage vulnerabilities using machine learning, threat intelligence, and behavioral analytics. For example, identify unpatched devices, open ports, unauthorized applications, unauthorized connections, changes to device configurations, PLC code, firmware, and more. Run searches in historical traffic across all relevant dimensions and protocols. Access full fidelity PC APS to drill down further. Detect advanced threats that you may have missed by static indicators of compromise, IOCs, such as zero-day malware, fileless malware, and living off the land tactics. Respond to threats by integrating with Microsoft services such as Microsoft Sentinel, other partner systems, and APIs. Integrate with Security Information and Event Management (SIEM) services, Security Operations and Response (SOR) services, Extended Detection and Response (XDR) services, and more.